as we go through this, the first thing that we're going to do is we're going to look at a sine curve. Now, I'm going to put the A in the front there, and I'm going to put a B back here with the X. Okay? And I'm going to talk about what the A and the B do here in just a second. All right? But a sine curve, and how I draw these is I will make, it's kind of the X and Y axis, except for I make my X axis go longer because they are going to ride like a wave. Okay? So for all these different sine ones, sine and cosine especially, this part doesn't necessarily have to be very tall, the y-axis, but the x-axis will have to be a little bit further. What you're going to be responsible for is you're going to be responsible for graphing what we call one period or one cycle, which we'll talk about how I get that in just a second. Okay, now, how a sine curve looks is a sine curve will look like this and keep continuing to go in that direction. Okay, that's what a sine curve will look like. Now, how high up and how far down I go is this number right here. I'm going to start off by giving you the basic one, the 1. It goes up 1 or down 1. That is known as its amp. The amplitude of a sine or cosine curve is how high up or down you have to go off of the line that goes in the middle. Does that make sense? So if I told you that the amp was 3, you would go up how high? And then how far down would you go? Right, exactly. Okay, now, the one thing about the sine and cosine curve especially is that these things will repeat themselves over and over and over forever and ever and ever. If anybody ever asks you for what's the domain of this function, it's all real numbers, because it will always go forever from the left and to the right. I don't ask you for the domain, but if anybody ever did, that's what the domain would be. So the amp is this high point right here. That's what the amp is. It's also the same right there and right there. The next number that we need to look at is, notice how from here to about here, do you notice how the pattern is going to start repeating itself? Do you guys see that? Okay, now, from here to there is known as its period or cycle. Okay, and we're going to find that based on one number that's in our formula. Okay, so the amplitude will tell us how high the graph goes. The period number will tell us how far it stretches out, and then as far as when it starts repeating with it. Okay? For both of these, whether it's sine or cosine, both of them, the amp is found by taking the absolute value of A. Why do I take the absolute value? Because it's the distance. Amp is how high up or how far down. That's a distance. Okay? The period is found by taking 2 pi divided by the absolute value of B. That's how you find the period. So whatever number is in that B position, you put that into that formula. Whatever number is in the A position, you put that in the formula. Now the one thing I want you guys to notice about the sine curve that I put up here, notice where I started it. Where did I put this thing running through? 0 or the origin. Okay? Now, this whole thing here would be one solid period. Where do you think this is in relation to the end of the period and the starting point? Halfway. It is. Okay? This would be halfway through right there. Now, Brooks, let's see if you can figure this out. The high point that's supposed to be right here, where do you think that is in relation to these two pieces? Where do you think the high point is in relation to this part where it crosses and this part where it starts? Right, in the middle. Good. What about for here? It's also in the center. What you're going to be doing when it comes to sine and cosine curves is you're going to be figuring out, you're going to break the line into fourths. That's what you're going to do. Whatever the period is, cut it in half again, and cut it in there. You're going to break it into 4 equal zones. Okay? So you're going to get used to making stuff into fourths. All right. But the main thing with the sine curve that I wanted to point out to you is where it started. It starts at 0, 0. Okay? The amp is how high up we go. The period is when it starts repeating itself. A cosine curve looks the same period and amplitude is done the same way. The amplitude is the absolute value of A. The period is still done by taking 2 pi divided by the absolute value of B. Everything about that's all the same. It's the starting point that is different. If the amp is up here, now this time when you draw a cosine curve, it starts up here. That's a pretty good curve, isn't it? Okay, so that's what happens with this one. The thing that I want you to, or wanted to point out to you, is right there. That's the main thing with this. Both of these two curves are actually the same if you were to shift it. However, it's where it starts at. The cosine curve will start at the amp, okay, at least for this first day, and then the sine curve will start at the origin. That's the only difference between those two things. Everything else about them is the same. Is everybody okay with that so far? All right. So if I gave you something like this, if I said y equals 4 the sine of x, here's what you're going to be asked to do. You're going to be asked to identify the amp, identify its period, sketch the graph. That's all you got to do. The whole assignment. So, what number is in the A position?
4.
So my amp is 4. What number is in the B position?
0.
Nope. 1. Abby, for that one, it wouldn't be 0 because 0 times anything would be 0. If there's no number listed, it's understood to be a 1. Okay? So that means we're going to take 2 pi and divide it by 1. What's 2 pi divided by 1? 2 pi. Very good, Isaac. All right, now as far as graphing it goes, this is how it's done. So I make my axes like that. I'm going to go 1, 2, 3, 4 up here. 1, 2, 3, 4 down there. Why do you think I went 4? Because of the amp. Here's something else that I do. I will make this dotted line. We've talked about those in other contexts as far as what they're called asymptotes. Remember those things that come up right up to it but can never cross it? That's kind of where I draw those to help me know that, hey, it's supposed to be contained inside that. That wave's not going to jump out outside of those lines. I know the high and low points are going to be hitting there. Okay? Everybody okay with that? All right. What was the period? 2 pi. So that means I'm going to draw a line out here and I'm going to say 2 pi. Now, Jacob, what's half of 2?
1.
Yay! So about halfway through there, I'm going to have 1 pi. Skylar, what's half of 1? 1/2. Yay! So that's 1/2 pi, or pi divided by 2, or 0.5 pi. Do not put 3.14 in there. I don't want to know what those decimals are. Leave them in terms of pi. There's one spot that's missing. Where should it go?
Halfway between the 1 and 2 pi.
Brianna, do you know what number is halfway between 1 and 2? 1.5. Or 3/2. Or 3 pi over 2. Or 1.5 pi. All of those are acceptable. As long as you get the pi there. Everybody okay with that? So you got your numbers. Honestly, I think that's going to be your hardest part today. Is figuring out or cutting it into fourths. Now something I shared with second hour, maybe this helps you, maybe it doesn't. But this seems to be the tricky number. The one that would go in between the 1 and the 2. So what I did with this is once I got half and I got half of that, well this is so each one of these right here from here to here is a half, plus another half is 1 whole, plus another half is 3.5, plus another half is 2. You can do that for every single one of them. Okay, so even if it wasn't a half, if it was like 1/16, 2/16, 3/16, 4/16, now you have your numbers. Okay? Now, as far as the sine curve go, the sine curve starts at the origin, right? That's what we said. So it starts here. It also ends at the period. Where else did it hit the x-axis? At the halfway point. Right. And then Brooks told me that the high point was halfway between there, wasn't it? Do you remember that, Brooks? So that halfway point between there, that's right here. And the low point was halfway between those two. That's right there. What do you think I'm going to do with those 5 dots? Yes. And I have now just graphed 1 period's worth. Now, this thing could go on forever if we wanted it to, if we needed it to. If it ever were to say graph 2 periods worth, what I would do is I would continue on in this pattern, adding a half every time and getting out to where it was 4 pi, and just keep riding the wave. Okay? What do you think? Not too bad? We'll see. Okay? That was a sine curve. A cosine one, yeah, that's a good one, has y equals 1/2 the cosine of 2 pi x. All right, first things first, let's identify the amp. What's in the A? What's the absolute value of 1/2? 1/2. Thank you, Abby. To finding your period, you take 2 pi and divide it by the number that's in the B spot. What is in the B spot? 2 pi. Good job, Jacob. Don't sound so surprised. Now, when I take, no matter what it is, if I were to take 2 pi divided by 2 pi, or something divided by itself, what number do I get? 1. Not itself. Which, I say that because some of you did that on your test last week. You had like the whatever it was over this, but then you said it was that answer instead of 1. So, that's my period, that's my amp. So I'm going to go make my sketch. So if this is at 1 unit high, halfway in there is going to be my amp. Halfway in there is going to be my amp. So that is as high or as low as it's going to go. Is everybody okay with that? Does that make sense? Okay, now I'm going to make this line out here at 1. What's half of 1? Yes. What's half of a half? 1/4. What's halfway between a half and 1? 3/4. Okay, now, just so that you guys understand this. This is what I was talking about with the second hour. See how that's a 1/4 here? One more, 1/4 would be 2/4, but 2/4 reduces down to 1/2. 3/4, 4/4 reduces down to 1. So now I have my period. I have everything on there. Cosine, though, starts where? Does it start on the axis or up at the amp? Up at the amp. Guess what it also does? It also finishes at the amp. This one did not, it was a wave, but it didn't look like the other wave like it looked like that. This one looked more like a V shape. So halfway there, see how this was up high here and up high here? What do you think it's going to do at the halfway point? Go down at the amp. Anybody want to guess of where it crosses the x-axis? One-fourth and 3/4, right? They're halfway points. And then I make my curve, and again it's a curve, it's not a V shape. Nice and smooth. And I'm done. It's all about breaking things into fourths. Okay? Every single one of them will start that way today. Now in a couple days when we talk about shifting them, then we'll shift everything over or we'll flip it over. But other than that, everything so far is all the same. Sine and cosine are pretty much the same types of things. The third type of graph that you're going to have is you're going to have the tangent graph. Now, tangent curves are different. They look different than the others. The period is found by taking pi divided by b, or the absolute value of b. And a new terminology for you guys is called a vertical asymptote. What a vertical asymptote is like an imaginary line that the thing's going to ride alongside but never actually cross over. Kind of like if I were to throw a marble at this glass thing, not throw it this way, but if I were to roll a marble on here, it hit this thing, then it wouldn't be able to go further, right? But pretend it can't actually hit there. It has to stop. Those of you with dogs, do any of you have one of those invisible fences? Or have you heard of one? You have one? Okay. Collar? As soon as it goes by, okay? That's what a vertical asymptote is. It's an invisible thing that you can't see, but you know it's supposed to ride alongside it, meaning it's going to be there eventually. How you would have it is you'd have pi over 2 times the absolute value of b. Notice the a didn't do anything in my formulas that I'm creating. What a does, which has been a long time since you've talked about it, but a in the front like that being multiplied would stretch it or shrink it. So that way the curve is not going to be, it's going to be skinnier or wider depending on if that number is big or small. We're not going to usually or use that necessarily today. We will in a couple of days. The way tangent curves look is they look different than the other two, by the way. What you would do is you would find your vertical asymptotes and you put one on this side, one on this side. And then the vertical asymptote, or the tangent graph itself, comes up here, crosses through there, and then rides up that asymptote. That's what a tangent curve looks like. That's 1 period's worth. Now, if I were to ask you to do 2 periods worth, you'd add the period over here, find the halfway point, and you'd ride it alongside here just like that. That is how tangent graphs will look. And they'll just keep doing that forever. Okay? It depends on how many periods they want you to do. Most of the ones that I'm going to tell you to do is just going to be 1 period's worth anyway. All right. So a tangent curve, then, just so that you have an example, it has y equals 2 times the tangent of 3x. Now again, the 2 that was in the A positioning, not going to necessarily use it. Just know that it's going to go up, get stretched out a little bit more. But the 3 is important. First thing that I'm going to find is I'm going to find its period. And the period again was pi divided by 3. So it's the absolute value of b. The vertical asymptote, I'm going to abbreviate as VA, just so that you guys know what a vertical asymptote, or VA, is referring to. It's referring to the vertical asymptote. I want you to times the bottom by 2. What's 2 times 3? 6. So then, on your graph, what you're going to do is you're going to go over here, pi over 6, and then back here, negative pi over 6. Now, what that did was you just created these imaginary lines that run north and south. And if you were to take pi over 6 plus pi over 6, you get 2 pi over 6, or 1/3. That's where the period is. You're splitting it in half. You're making it symmetrical. Does that make sense? Now, how do you draw this? Kind of looks like an S, right? But it's going to be a little bit more stretched out just because of the 2. So I'm going to come in here. And I have a hard time drawing those. I probably should have went down here more. That'll look a little bit better. There. That looks better. And that's 1 period's worth for the tangent graph. That's what they will look like. Now again, if they ask you to draw 2 periods worth, I would go and add pi over 3 to that, come up with another vertical asymptote, and I'd draw a second one, that look the same. If they had to do a third period, I'd add another pi over 3 over here, do another vertical asymptote, and do another curve. They only ever ask you to do 1 period's worth, but if they ask you to do 2 or 3, then you just keep adding them over. Corinna, are you okay? Because you look confused. Okay. So, if you guys turn to page 913, I'm going to help you get started. Number 6 says y equals the sine of 1/5 x. This is the first one in your assignment. First thing it's going to ask you to do, identify the amp, identify the period, sketch the graph. So what's the amp? 1. Now the period is found by taking, again, 2 pi divided by b. What's in your b? Fish, do you know how I get rid of a fraction inside of a fraction? What's the reciprocal of 1 over 5? And when I do that on the top, what's 2 pi times 5? Very good. So then when I go and sketch this out, how high up do I go? What's the amp, you guys? 1. So that means I just have 1 here. I personally like to do these little dotted lines just so that I know how high up I need to go or how far down I need to go. If you don't want to do that, that's your own personal choice. I don't care. All right, now how far out do I need to go before it repeats itself? 10 pi. So I make a mark out here at 10 pi. Is it important to label this? Yeah. You know why? Every single one of these graphs could look the same. You need to apply it to your specific situation. So in this case, that's why that you label these different parts. What's half of 10? What's half of that? I like to write 5 halves. You wrote 2.5 or 2.5, whatever. What's halfway between 5 and 10? Right? 7.5 or 15 halves or 7.5. All of those are acceptable answers. I like to write 15 halves. Is this a sine or cosine curve? Sine. Which means, where does it start? Good. Where does it end at? 10 pi. Where else does it cross at? 5 pi. Where does it hit its high point at? 5 halves. Where does it hit its low point at? 15 halves. Now what are you going to do with all those 5 dots? Connect them. Very good. That's what number 6 should look like. Done. Number 7 has y equals 4 cosine of x. Tasha, what's the amp? 4. Very good. Abby, do you know what the period is? Two pi. Because you'd take 2 pi divided by b, but b in this case is a 1. So 2 pi. Very good, Abby. Draw my thing. How far up am I going to go again, Tasha? 4. Good. 1, 2, 3, 4. 1, 2, 3, 4. I go out 2 pi. Abby, what's half of 2? What's half of 1? What's halfway between 1 and 2? 3 seconds? Or 1.5? Or 1 1/2? Absolutely. Now, Isaac, do I start at the 0 mark or at the amp mark? At the amp. When it's a cosine curve, you start at the amp. Then, where do I end it at? At the amp again. Where's the half? What do I do at the halfway point? That's your low point. And what do I do at the quarter points? You hit them. And then what do I do? Connect the dots. And do not make it V-shaped, although it looks very tempting to make it a V, because it's a curve. So you want to make it almost look like the analogy I used the other day, or for second hour, was a teacup. Those old-fashioned teacups that have the ends that curl out, right? Guys, if you don't know what a teacup is, when you have kids and a daughter, for instance, you might have some. Girls, do you know what I'm saying? Teacup? How the ends curl out? Okay. All right. What do you think of that? Not too bad? Okay, one more I want to do with you just because I want to do a tangent one. And that is, let's do 17. F of x equals 4 times the tangent of x. Now this time I'm not asking you for amp. I'm asking you for period. What number is in the period spot? Nope. 1. And what did I say the period was for tangent curves? Pi over b. So in this case, pi divided by 1 is just pi. The vertical asymptote is the other thing that I'm asking you for, and that's where you take the bottom of that. So if it was a 1, then you times it by 2. So what's the vertical asymptote at? Pi over 2. So that means on my graph, I'm going to make one that looks more centered. I'm going to go over here and make a dotted line, and go over here and make that same dotted line. Where are those supposed to be at again? Pi over 2, and then negative pi over 2. The reason why they're like that is because what if I add pi over 2 plus pi over 2? What do I get? 1 whole pi, or 1 period. Right? Just so that you guys are aware of that. If I were to take the distance here, which is a half, and distance here, which is a half, what's 1/2 plus 1/2? 1 whole, or what you have for your period. Right? What's the 4 do? It does. It stretches it out, which means that it would come in here, something like that, barely hit it like that. It's going to go through the 0, but it'd be stretched out. And that's what 17 should look like. It does not ask you to graph any more than that for periods. It just asks you for 1 period. So, what you need to identify. If it's a sine or cosine curve, you need to identify the amp, the period, graph it. If it's a tangent curve, you need to identify the period, the vertical asymptote, and then graph it. Okay? So, on page 913, 6 through 13, and 16 through 23.